Hey guys, Jeremy Blum here with the second Arduino tutorial sponsored by Element 14. Last week I gave you an intro to the Arduino and a bunch of aspects of using it and some intro programming. This week we're going to start talking about analog outputs on the Arduino that's done using PWM signals. If you don't know what PWM means or you're not really sure what the difference between digital and analog is, I strongly encourage you to watch this Tech Bits episode right here that I did a few months ago. Otherwise, we're going to be working on using some buttons. We're going to control LED brightness using those PWM signals. We're going to learn a little bit more about the Arduino programming environment. We're going to learn how to use functions in the Arduino programming environment, and a whole bunch of other great stuff. So let's get started. Your best friend when working with the Arduino, or any set of electronics for that matter, is going to be a breadboard. This is the first stop for prototyping your circuit and makes everything really easy. The way breadboard works is all these vertical pieces right here are vertical rails, usually connected to power or ground, and they're electrically connected the whole way through. So if you look on the left side, for example, you can see these two rails. I'll hook one up to power and one up to ground. Then in the middle, you have these bigger pieces of breadboard. These are connected horizontally across. Of course, not connected, though, through the middle. And you use those for mounting integrated circuits on there so you can connect the pins on each side of the circuit. And it's very useful for prototyping. Next thing we'll be using today are these resistors. Today I'm using a 220 ohm resistor to work with the LED because you want to make sure that you're not drawing too much current through it. And the other one is a 10K resistor that I'm going to use as a pull up or a pull down for the button. That'll keep the voltage level at ground when it's not pushed. I won't go into how to read resistors here, but you can look that up online. Just Google how to read resistor codes. It's really pretty straightforward. They're all color coded. That's how you can tell the values. An LED, or a light emitting diode, is directional like all diodes, so you need to make sure you put it in the circuit in the right direction. Some of them have little indicators on the plastic part. This one doesn't. This one you can tell which direction it is by the length of the leads. The shorter lead is the one that goes to ground. The last thing here is our push button. The push button works by you just basically push it down and it connects the leads on one side. So if we put our multimeter into diode mode, we can use it to actually see that. You can see when I touch the leads together that the reading on the screen goes to 0, indicating that there's a connection between the probes. The same thing should happen when we connect it to both sides of the button and we press on it. So here you can see that there's no connection. But if we keep the leads there and push down on the button, you can see that it goes down to 0, indicating that we've completed the circuit. Okay, so let's get our Arduino wired up with a push button so we can start writing some programs with it. First off, let's connect the ground from the Arduino and the power from the Arduino, the 5 volts, to rails on the breadboard so that we can use them. Plug a wire into the ground pin on the Arduino. I'll connect it to our left rail here. And now do the same thing with the 5 volt line. So plug it into the connector marked 5 volts, and we'll hook that up to the rail on the right side. Next up, we want to hook our little switch up. So we'll put it across this gap in the middle, pop it in there, just like that, and now we can go ahead and connect it. So what we'll do is we'll attach a pull-down resistor from one of the pins that can get connected on this side down to ground. So I'm going to use a 10K resistor for that. The exact value isn't really important here, but it should be relatively large. I usually choose 10K or 1K. So remember, our ground is our left side, so I'll hook that up into ground. And all this is going to do is make sure that when the push button is not being activated, that its value is pulled down to ground. Now we'll connect the other side of it up to the 5 volt line so that when we push it down, it goes to 5 volts and sends a digital 1 to the microcontroller. So hook that up right there. Now all we have to do is actually hook up the same place where the resistor is hooked into the button over to the Arduino. So let's do that. Plug one end of a wire into the side of the button that's pulled down to ground usually. And the other side I'm going to plug into pin 8. You can choose any pin you like, really. They can all do both digital input and output, but I'll pick 8. And that's it. We can now use this circuit to send a digital 1 or 0 to the Arduino. Okay, now I'm just going to put our external LED on pin 13 of the Arduino. Remember 13 already has an LED on it, but I'm going to put another one in there. Make sure the short pin goes to ground, as we mentioned before, and just like that. You don't need to put a resistor in here because there's already a resistor for the internal LED on pin 13. Great, now that we have our circuit set up, let's write a program to control it. To start off, let's just have it say when we hold the button down, and therefore it's getting a digital 1 on pin 8, keep the LED on. This is simple, straightforward. In fact, you don't even need a microcontroller to do this, but this is a good place to get us started. So let's define our variables up at the top that we're going to use. We'll have a pin that the switch is connected to, and that's pin 8, and a pin that the LED is connected to, which is pin 13. As always, we're going to need our setup function. So let's do that. In our setup function now, instead of just having an output, we have an input as well. So let's set both of those. Just as with last time, we use the pin mode command. And we have our switch pin, which is an input. And then we also have our LED pin, which is an output. Great, that's all we need in the setup. Now let's do our loop. So we're going to read the value of the switch, and if it's high, we'll set the LED high, and if it's low, we'll set the LED low. It's just that simple. So we're going to use some if statements to do that, to look at the values. So if we do a digital read of the switch pin, remember it's digital because it's just a switch. There's no analog values here. It's either 0 volts or it's 5 volts. So if we look at the switch pin, and if that's high, or if it's at 5 volts currently, we're going to make sure that the LED is high. Otherwise, we're going to make sure the LED is low. And of course, it doesn't matter if it's already assigned to one of these, it'll just keep it at that. Our sketch is uploaded, so let's see if it does what we want. And sure enough, I hold down the button and the LED stays on. Great, but that's kind of boring, right? You can do that without even using a microcontroller. So let's make it a little bit more interesting. Let's try to make it when we push the button, the LED turns on, and when we push the button again, the LED turns off. That would be a little bit more annoying to do without a microcontroller. So let's try to do that. So if we're not going to be using this system to toggle the LED on and off, the first thing we have to do is add 2 new variables up here that are going to allow us to keep track of the state of the system. We'll make these booleans. Booleans can basically just have 2 values, true or false, high or low, on or off, 0 or 1. They all basically mean the same thing. We'll keep track of what the button was in the previous loop. Of course, it'll initially be set to low. And we'll make a boolean to keep track of the current state of the LED so that we can toggle it. And this will allow us to check things within the loop and set them to what they need to be. The setup function is going to remain the same as before. We still just have 2 things that we're controlling. But we're definitely going to have to change some stuff down here, right? So the first thing we're going to have to do is we're no longer just checking to see if it's high. We're checking to see if it is currently high and was previously low, because that would mean that the button was just pressed. So let's check for that. Instead of using this if statement that we have here now, we'll still read the switch pin and we want to see if that's high, but we want to see if that was high and the last button was read as low, right? And now what we're going to do, instead of writing to it right here, we'll still do that later, so let's copy that down there, but we're going to write a variable now. So we're going to use that LED on that we created before and just flip that value. So what that exclamation mark there does is just invert it from what it previously was, and it will make it the opposite value, which is perfect. That's exactly what we want it to do. We want to switch it on or off. And then let's make sure we update our variable that's going to keep track of everything. Obviously, this is going to equal high now because that's part of the if statement. We read that it was high. Okay, otherwise, we're not going to write here anymore. Like I said, we're going to do that afterwards. But we need to still set the value of last button because we set it here and we need to have it set. So let's set last button. And that's going to equal to whatever value we're currently at here. And you can do the digital read just once at the top and then use a variable to assign it, but for the purpose of this program, this will work just fine. And now we're not writing it always high, right? We're just going to write it to the value of LED on. Okay, and that should do it. That should do exactly what we need. So let's see how that works. That's weird. That's definitely not what we expect, huh? Oh, that's interesting. That time it went on, but the other times it didn't. Okay, that time it went off, and that time it went on. Oh, that time it stayed on when I clicked it. Something's definitely not right here. Why is this only turning on and off some of the time? If you guessed that the switch is bouncing, you'd be correct. Here's what a switch looks like when it's bouncing up and down. Basically what that means is with a simple switch like this, you have to worry about the signal going up and down before it stays at a certain state, whether it's pressed or unpressed. So we're going to have to write something into our software that deals with that. So let's go do that now. So let's add a function to debounce this switch in software. You can do this in hardware also, but for now we'll debounce in software. So the first thing we're going to do that's new is we're going to make our own function. And it's going to return a Boolean, so I'm going to define it as a Boolean, whereas these other ones don't return anything. This is going to return a Boolean, and we're going to call the function debounce. And we'll also feed it a Boolean value, which in the function will be referred to as last. And this will be the last state of the switch that will pass it. Just like in the other functions that are defined by default in Arduino, you enclose it in brackets. So what we just did is we made a function called debounce, just like digital read is a function with an input switch pin. Debounce is now a function with input last. And we can now define that. First, let's make two more global, or make another global variable here that's going to keep track of what the current button value is. That'll also be a Boolean, and we'll call that current button. And we'll need this to use it with our debounce function. And as before, it'll be set with a default value of low. Okay, and now let's fill in this function here. So the first thing we're going to need to do is we're going to need to determine what the current value of the switch is. So we'll set that equal to current, and we'll do a digital read of that switch pin. Okay, now so what this is doing is this is just setting the value current to the input that it reads from the switch pin. And now we're going to have to compare that to the last one. So since we passed it the last value, we can now compare it and see if they're equal. That'll tell us if someone hit the switch. So if last is not equal to current, that's what the exclamation mark means, remember, we'll do something. So if the switch changed states, first thing we're going to do is we're going to delay by 5 milliseconds. And what this is going to do is this is going to give the switch enough time to finish debouncing, but it's short enough that your finger will not yet have been released from the button because it's basically faster than we can move. Then what we'll do is we'll read it again. And this is just a very simple way to do a debounce, but it works quite well. So what we're doing here by reading this again is we're waiting for it to finish. We're detecting that it changed, waiting for it to finish bouncing by putting this delay in here, and then reading it again where it's presumably at its steady value. And then we can return that value from the function. So we'll return current, and that should give us our debounced value. And now, of course, we'll have to change our loop down here to work with that, right? So first thing we're going to have to do is actually run that function. So we'll set current button equal to the value that's returned from that, because remember, it returns the current button state. So current button is going to equal the debounce function, and we're going to pass it last button. Great. Okay, and now if last button, we don't need to read it anymore now because the debounce function is doing that for us. If last button is low and current button, remember the value of current button has been debounced already, so we don't have to worry about it, is high, that means someone has just pressed the switch, which is exactly what we're looking for. So now we can still invert this like we did before, but we no longer need to track this because the debounce function is taking care of that. In fact, we can get rid of our else statement also. It's also taken care of in the debounce. But what we will need to do is save our last button here and make sure it gets set always to the proper value. And that'll just get set back to current button once we've set current button so that we can use it next time through the loop. And now this is going to write LED on as before, and that should do just what we want. So let's run that. Click it, it goes on, click it, it goes off. Seems to work pretty reliably. It looks like our switch debouncing function worked. Great job. Alright, so that's pretty cool, but now let's try to make the LED change brightness when we click the button. To do that, we're going to use something called pulse width modulation, which is basically a way of emulating an analog output for an LED or basically any other device. However, only some of the digital pins on the Arduino support that, so we have to make sure we pick one that does. If you look at the marking on the board here, you can see that PWM pins are marked with a little tilde sign. And 13, the one that we currently have the LED hooked up to, is not one of them. So let's pick another one. We'll pick 11. 11 is a PWM pin. So we're going to hook our LED up to pin 11 using the breadboard now. First, make sure you unplug the Arduino. We don't want to do anything while there's power connected. Pop out our LED, and let's put it over on our breadboard, making sure we hook the short end into our ground. Our ground is our left side of the rail over here. Great, so that LED is going between that line over there and ground. And now we can use a resistor to go from the Arduino through the LED to ground. And we'll hook that over into pin 11. Making sure that we're not shorting out any wires while we do that. Okay, this is going to be a piece of cake to fix in here. First off, we defined our LED pin up here, so let's make sure we change that to pin 11 because we changed the pin it's hooked up to. Next, we're going to change our LED on value, which is a Boolean, to an LED level variable. So when you're communicating with a PWM pin, you set it up as a value from 0 to 255 to control it, and that'll control the brightness of the LED. So instead of setting it to false, we'll set it equal to 0, and we'll change it from a Boolean to an integer. So now this can take on any value, but we're only going to concern ourselves with values between 0 and 255, which will set the brightness up. The debounce function can stay exactly as it is, and we're just going to change some things around over here now. So now, instead of saying flipping the value of LED on, we'll just increment its brightness. So we'll say LED level instead of LED on, and we'll say it's equal to its previous value plus 51. I chose 51 because it's 255 is divisible by it, but you can choose any number you want really. We're going to make sure we take care of cases above 255. But that'll work fine, and that'll give us 5 different increments. This will still set as before. Now the key thing we're going to have to do here is make sure that when we get up past 255, or when we click one more time, the LED goes back into the off state. So if the LED level is greater than 255, because we can't output values greater than 255, we're going to just set it back down to 0. Just like that, very simple. You don't actually even need to put it in brackets because it's just one line. You can put it right after it. And the only thing we're going to change here now is that instead of digital write, this is going to be an analog write. And instead of LED on, we changed our variable name to LED level. And that's it. Let's see how that works. And we can see, as I click it, the brightness of the LED increases until I click it and it goes back down to 0, where it starts all over again. Alright, that does it for this week's tutorial. I hope you guys enjoyed it and you got a lot out of it. As always, if you have any questions, feel free to ask me on YouTube, on Element 14, on my website, jeremyblum.com, whatever. I'm always happy to answer questions. I'm going to upload the source code from this episode to my website. I'll have a link down in the description below shortly after I upload it. And that's about it. I'll see you guys next week. We'll be talking about some basics of electrical engineering, voltage dividers, understanding current, resistance, things like that. Stuff that you need to do some really interesting stuff with the Arduino. Alright, sounds good. I can't wait to see you guys next week. Thanks a lot for watching. Thanks to Element 14 for helping me to sponsor this video series. They were kind enough to provide a lot of the materials that I'll be using to create these tutorials. Feel free to go visit their website at element14.com. Check out their community, which is a great place to talk to people about electronics, the Arduino, and basically anything else engineering related. And they also have a store where you can buy a lot of the parts that we'll be using in these videos.